Hey, it's me. I heard you were having some trouble with chemistry, so I was just gonna help you out, so here it goes. I'm gonna try and do this all in one take because I don't feel like editing. So I'm on the test preview right now. We need to know ionic naming, which I think you're pretty good at. There's a worksheet for it right here. This is a blank one, but practice in writing ionic compound names, and that's ite versus aid. I think once you do it a few times, you just kind of get the swing of it. Just know your common element symbols. You can go through your flashcards for that. And also the valence electrons you just find with the Roman numeral row number. And it'll have a charge that Ms. Cladkey will write in if it's not, if it's like a transition metal or something. It says we need to know Lewis dot symbols. Okay, Lewis dot symbols, and I'll do this all in one thing. So we're going to need to know how to draw a chemical reaction anyways. I'm going to do aluminum and bromine. So if we have an aluminum, and the periodic table, I have one of these. Here it is. So aluminum has 1, 2, 3. And remember the strangers on a bus rule, so they don't want to be touching each other. And bromine comes along, and bromine has, I think, 7. 1, 2, 3, 4, 5, 6, 7. Okay. A photon comes along, strikes one of aluminum's electrons, and gives it over to bromine. Aluminum is a metal, it's a loser, that's why it is. But we still have 2 more photons to give, 2 more electrons to give, so we need to give those away. It's the holiday season, let's be generous. So basically, in order to get rid of all 3 of these, you're going to need 3 bromines. Makes sense. So it would just be Al Br3. Okay. And that is a Lewis dot structure. Or what do they call it? A Lewis dot symbol. Now, for the Lewis structure for aluminum bromine, you have aluminum in the center, because it's the first one in the formula. Just so you know. Well, let's see, how would I do this? Aluminum. Hold on. I drew one earlier. I did arsenic fluoride. I feel like that'll sort of cover more, so I'm going to just start this over. Arsenic fluoride, the formula is like that. So notice it's a charged one. So first we're going to figure out the number of electrons the final structure should add up to. So arsenic has 5 to give, and fluorine has 7 to give times 3 because there are 3 of them. That's 21. 21 plus 5 is 26, but remember, we need to subtract 2 because there are 2 plus charge. So minus 2 is 24. So that should be the final number that we come out with. You're familiar with that. Now we just draw the skeleton structure. So slap AS on there, throw 3 covalent bonds on. Finish it off with some beautiful little fluorines. And then use the octet rule to make everybody happy. So 8 is great. Don't forget to make the center one happy as well. I always forget that. So you got to make sure everything's good. And then recount them up. This one equals 26, and 26 does not equal 24, so this is not correct. That means we have to add in a double bond. So you just do that by taking off 2 dots from the center. I'm going to take those 2, and 2 dots from any of the surrounding ones. So I will redraw it. Arsenic, fluoride, 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 double bond. And then make sure everybody is happy. Each bond counts for 2 for each one. So that makes everybody happy, and 24 is equal to 24, so it is correct. Only one last step, because it is a sourpuss and it has a charge. We gotta put it in a house and give it an address, which is its charge. So that is the final Lewis structure. And the last thing you need is the list of real-life materials labeled as either ionic or molecular. Ionic bonds do not smell. They're things like salts, and they take a lot of dissociation energy, bond dissociation energy to break. So they don't have any things that float up into our scent receptors. Intermolecular bonds are very, very weak. They're the things like in hydrogen bonds. Those are the only intermolecular bonds we know. And remember, hydrogens like to have fun. Fluorine, nitrogen, and oxygen. Oxygen, nitrogen, fluorine have a partial negative. Hydrogen has a partial positive. It makes it really polar. And when I bumped you, that was a hydrogen bond earlier today. And so intermolecular are very weak. If you can smell it, it's molecular. If you can't, it's ionic. Also, you can go on Miss Clacky's PowerPoint. It has like bones and things like that. Most foods are molecular. Most like rigid things are ionic. So know that. Multiple choice is going to be a little bit difficult. It's difficult for everybody. Just really think it through. Think through everything you know. Go over the PowerPoints right before. No Ono Sokopo. That's just a memorizational thing. And the matching, that's always difficult for me. But I think all in all, you're going to be okay. I'm going to be okay. And good luck.